All right, and the last thing that we're going to look at in this section is the different types of equations. It does seem like you will always have a solution to an equation. Now, we did see one type where there was no solution, so we need to consider that type of equation as well. But there's three different types of equations. Now, the first type is what we call a conditional equation. This is the one you're used to seeing, the one that typically happens. And a conditional equation is an equation that has at least one real solution. Now, typically what happens is there is one solution, but sometimes you can have more than one. Sometimes you can have two or even three solutions. So the idea here is that you have at least one solution, at least one answer. So let's take a look at an example here. Let's say we have 5x minus 20 equals 4 times x minus 2. Now you know that to solve that, all you have to do is distribute that 4 through. And whenever you distribute the 4 through, you get 5x minus 20 equals 4x minus 8. You know that you need to subtract the 4x, and you get x minus 20 equals negative 8. Sign in front's the sign that goes, that's a negative 8. Add the 20, and that gives you x equals 12. So that's going to be your solution to that equation. Notice that I did get at least one solution. Granted, only one solution, but I got at least one solution. So my solution set, because remember, I'm generating a set of numbers here. The set of numbers that I can plug in here for the x and in here for the x and get this left side to equal that right side. So anything that's going to work is going to be a member of my solution set. And remember, some books will have you write your answer this way, meaning that you're generating a set of numbers. This is the only number in that set because this set of numbers is going to be everything that's going to work and make the left side equal the right side. In this case, there's only one number that will do that. There's only one number in the solution set. So typically what we do though is we write our solution set as this, like our variable equals some number. That's usually what we do. That's the case of what I did right here. But sometimes you'll write your solution set this way, and then you'll put that number inside your solution set. Those are either of the two ways that you'll write your solution set if it's a conditional equation. Now, there are other types of equations. Let's say, for instance, that we have a case where, let's call it an inconsistent, sorry, that noise you're hearing is the plow scraping my road out in front of my house. Apologize for the noise. But an inconsistent equation. Now leave yourself a little bit of space here and we'll fill in what happens with the inconsistent. But let's take a look at an example because it'll make a whole lot more sense seeing the example. Let's say that we have 5x minus 20 equals 5 times x minus 10. And once again, you know that to solve that equation, you have to distribute your 5 through. And so when you distribute the 5, you get a 5x minus 50. And you know that you need to subtract 5x from both sides. That gives you a negative 20 equals a negative 50. Now this is the point in time where I start having a panic attack and I go, now wait a minute, I've wiped out all my variables, there's no variables left, I must have done something wrong. So I go back and I double check what I did and I distribute my 5x through and I say, no, I did nothing wrong, I subtracted my 5x from both sides. I did every step right, there's nothing that I did wrong. Well, what this is saying is a negative 20 equals a negative 50. Well, I know a negative 20 does not equal a negative 50. I know they're not the same number. So what that's telling me, remember, I'm trying to figure out what number can I put right in here for this x and right in here for this x and get this left side to equal this right, get the left side to equal the right side. This is telling me that since negative 20 does not equal negative 50, there is no number at all that I can plug in there and get the left side to equal the right side. This is what we call an inconsistent equation. An inconsistent equation is an equation That is not true for any real numbers. Nothing's going to work. There's absolutely no number that I can plug in here for each of these x's and get the left side to equal the right side. So in other words, what's going to happen here is I'm not going to have any solutions at all. There are no solutions. But remember, we have to figure out how we're going to write our solution. When it was a conditional equation, we wrote our answer either this way or this way. This is the number that will work. This is the set. The set of numbers that will work is this number in the set. But here, I can't really write a set. So the way that I write my solution set, because I'm still looking for a set of numbers that'll work, the set of numbers is the empty set. Now we can write it this way. That's the set that's empty. Or remember, we said that we can write it as the null set. Null set and empty set are the very same thing. So that's how you write your answer if you have an inconsistent equation, meaning that absolutely nothing will work. And the last of the types of equations is what we call an identity equation. Once again, leave a little bit of space here because it's easier to just take a look at an example and it makes much more sense. So let's say we've got 5x minus 20 and it equals 5 parentheses x minus 2 minus 10. Now we know that to solve this equation what we have to do is we have to distribute the 5 through. And remember, distribute it only through the parentheses. Don't distribute it all the way back here to the negative 10. And you'll get a 5x minus 10 minus 10. At that point we know we need to combine up the like terms that are here, and that will give us a 5x minus 20. Then we subtract the 5x, and that gives us a negative 20 equals a negative 20. And this is once again the point where I have a little heart attack thinking I did something wrong. But as I go back and check my steps, I see that no, I didn't do anything wrong at all. Everything's done correctly, even right down to subtracting the 5x from both sides. But I've wiped out all the variables, and I'm just left with a negative 20 equals negative 20. But I look at that statement, and it tells me that negative 20 is a negative 20. Well, that's absolutely true. And that's kind of like looking in the mirror. And when you look in the mirror and you see your reflection, you see the very same thing in the mirror that's standing in front of the mirror. That's kind of what's happening here. And so it's almost like when you look in the mirror to sort of, you see your identity. So this is what we call an identity when you see the very same thing. And an identity simply means, because remember, we're looking for all the numbers that we can plug back in here for this x and for this x and get this left side to equal this right side. Well, when we get down to wiping out all the variables and one number is the same thing as the other number on the other side of the equal sign, then that means every single number can be plugged back in here for this x and get the left side to equal the right side. So in other words, an identity is simply an equation that is true for all real numbers. Every single number will work. Every single number that you can think of, you can plug in there and get the left side to equal the right side. So that means in terms of the number of solutions, well, we have infinitely many solutions. If everything will work, then there's an infinite number of numbers that we can plug in there and get the left side to equal the right side. But remember, what we're trying to figure out is, how do we write our answer? How do we express that? Because saying infinitely many solutions doesn't tell you what the solutions are. We have to find a way to express all the numbers or solutions. So our solution set, the way that we write it, remember we are talking about a set here, and a set we express with braces, and this is the set of all numbers such that the number is a real number. And so that's how you write your answer whenever you come down to an identity, meaning that every single number will work. So at the end of this, I don't circle this. This is not my answer. What I write for my answer is x such that x is a real number. That is what my answer is. The set of all numbers such that the number is a real number. Now, if you had a different variable other than an x, you would put x such that braces n such that n is a real number, or m such that m is a real number, or whatever variable you're using. But that's how you express your answer when you have an identity. And those are the three different types of equations: your conditional, where you have at least one solution; your inconsistent, where you have no solution; and your identity, where everything's a solution. And that is all.